Thank you again for joining us today, day 2 of AMexpo 2020. Hi, my name is Robert Piccinich. I'm an account manager here at SolidCAD, part of the advanced manufacturing team. I hope everybody had a chance yesterday to sit on some of the great presentations. Another day today, some awesome topics, and of course, some amazing presenters. With that, I'd like to introduce the presenter today, Victor from Proto 3000. Say hi, Victor.
Hi, everybody.
Good stuff. Well, SolidCAD and Proto 3000 have, we've had a long relationship where we share leads between the two companies. Sometimes their clients need some design software, something like Inventor or say Fusion 360, or even products that specialize in 3D printing like Autodesk NetFab. And of course, our clients sometimes come to us and say, hey, where can we buy some 3D printers? Or do you know anybody with 3D printing services, or even 3D scanning for reverse engineering? Well, that's where the experts at Proto 3000 come in handy, and they fit the right solution for our clients or their clients. And we want to make this very interactive today, so please post your questions on the Q&A panel, and we'll attempt to answer all your questions during the session today. So, Victor, it's all yours.
Hi, everybody. My name is Victor Talani. I lead business development for our additive manufacturing department. And today, I'm just going to share my screen over here. We'll do about a half-an-hour presentation on 3D printing and finding a fit in your design and manufacturing workflow. So 3D printing has been around for quite a long time. And more, it is being replaced with additive manufacturing for folks that are serious about using 3D printing for manufacturing purposes and for integrating it into commercial and industrial applications. So I'll go over with sort of cover the latest and greatest in 3D printing in terms of some of the new technologies, the materials, and some applications. And along the way, feel free to ask some questions, and we'll go from there. Furthermore, if you do have any questions afterwards, you can reach out to us directly as well. My email address is victor@proto3000.com. So feel free to reach out to us afterwards. So let's get this going over here. So the agenda and the objective of today's presentation is what is additive manufacturing and what's the point? We'll go over some additive manufacturing processes, some materials and capabilities, and when does additive manufacturing make sense? Where's the fit? And then we'll cover some industry applications and case studies, and then go over a quick Q&A. There's quite a bit of material over here, so if there's too much information, feel free to take some screenshots and things like that. And of course, like I said, post some questions that we can answer as I'm doing the presentation. So I'll give you a quick history about Proto 3000. We've been around for 10 plus years. Actually, we just had our 13th anniversary this year. And we're located in Vaughan, Ontario. We also have support offices in Laval, Quebec, and Atlanta, Georgia. We have a 16,000 square foot ISO certified manufacturing facility in Vaughan, where we do the majority of our work, whether that may be 3D printing, 3D scanning, or all of our engineering work. So far, I think we've counted up to about 500,000 plus parts we've produced, completed about 10,000 plus projects, and 30 plus industrial additive manufacturing systems we have in-house, and we're getting more, and we'll talk about that a little bit more. And we work with thousands of customers across the globe, actually. So these are sort of some of the industry verticals that we work with: aerospace, automotive, consumer, healthcare, and really everything else. And it's on a daily basis, we're working with all sorts of industry verticals at any point of time. More and more, these industries are finding all sorts of new applications and uses and benefits of additive manufacturing, and we're there to help them and guide them through the process. So in terms of Proto 3000, we have 3 different areas that we focus on in terms of our additive manufacturing and advanced manufacturing solutions. One's the design side of things, using software and our design teams to help our clients do that. And then the additive part of it, where we sell equipment as well as we offer additive manufacturing as a service whenever our clients want, using different technologies. And then metrology and 3D scanning is another big part of our business, where we help our clients 3D scan, inspect, reverse engineer, using our 3D scanning technologies. Now, a lot of people ask us, why is manufacturing changing? And well, honestly, if the last 6 months is any indication, because it needs to. In the last 6 months, we've actually worked with quite a number of clients who have got a hold of us and said, hey, we're having massive disruptions in our supply chain. Can you help us? So that's where we've been able to use a lot of our additive manufacturing technologies and put it to the test. And I'm telling you, I'm doing this presentation today, and we're just wrapping up close to about a 500,000 face shield order that we're satisfying for some of our medical clients. So, we're able to turn things around pretty quickly, and especially in the last about 6 months, additive manufacturing has played a massive role in terms of filling in some of the issues in the supply chains and things like that. So what is additive manufacturing? Generally, additive manufacturing is the process of joining material together. Whereas in the traditional manufacturing, you would take a block of something and you'll machine it off. We start with nothing and we grow it up from there. There are lots of different technologies that include this, but generally you start with a 3-dimensional CAD file. We are able to slice it, or we're able to design it in a way and develop it in a way so that it can be read by a 3D printing machine, and then we send it to the 3D printer for producing. GE, General Electric, has actually a really good saying that says additive manufacturing is a transformative approach to industrial production that enables the creation of lighter, stronger parts and systems. This is very interesting because now you don't necessarily have to just make one part. You can actually make assemblies that are functioning as well. Additive manufacturing delivers a perfect trifecta of improved performance, complex geometries, and simplified fabrication. So, why additive manufacturing? Well, usually when a lot of people ask us for why additive manufacturing, they already are working on a traditional pathway or workflow. And the traditional workflow is already designed, and it's very compliant in a way. Now, with additive manufacturing, when most people started integrating additive manufacturing was for rapid prototyping. With rapid prototyping, it shortened up the product development life cycles for a lot of companies. In fact, I used to work on an injection molding company where we were able to tighten up that development life cycle from about 12 months all the way down to about 3, because we were able to use 3D printing and additive manufacturing for prototyping purposes. So by the time you went to actually manufacturing the final product, you're now at version 8 or version 9 of that product generation, rather than just having a single revision of the product. Now, once you totally digitally optimize the designs, it opens up a whole different ballgame, right? The typical application or the way that additive manufacturing was integrated was, hey, we want to make this one part using a classical method. What 3D printing technologies are there to match it? Well, the new way of looking at it is a lot of companies and all of our clients are thinking, if we design this product for additive manufacturing, what would that look like? And that opens up a whole bunch of different breakthroughs in terms of functionality of the products, the application, the workflows, inventory, and everything. Because it's a highly optimized process, if and when the designers and the product developers start thinking about additive manufacturing, and right at the beginning of the product development lifecycle, we have seen a number of breakthroughs in the products and the way that they reach the market. So additive manufacturing equals design freedom and innovation. So when you use additive manufacturing design and production workflows, you can consolidate assemblies, you can simplify your supply chain, obviously, improve the functionality of the part and the performance of the part. And also you can unlock advanced sort of lightweight, high strength geometries and topologies using some of the great softwares that we have available. You can essentially eliminate non-cost effective or potentially poor performing parts as well. So it transforms the way that you look at the way that you design a product, the way that the product functions at the end of the day, and maybe even sometimes sort of the environmental impact and the sustainability of the product and the business as well. So global adoption drivers for additive manufacturing is sort of right across the board. Obviously, low production has been a great adoption driver. A lot of companies that are looking for low production or high complexity or multi-sized production lines are looking into additive manufacturing, especially considering the new technologies and materials that are out there. Life cycle sustainability is a big thing. Additive manufacturing is a highly optimized manufacturing process. There's as little waste as possible when you manufacture using 3D printing technologies. So as a result of that, companies can now use additive manufacturing as part of their sustainability value set. Increased part functionality. You know, one of the ways that that you can essentially design more functionality into a certain part where it may not have been able to be manufactured using a classical method, you can now use 3D printing or additive manufacturing to make these parts. Supply chain realignment is a massive driver in additive manufacturing. All the way from the beginning of getting prototypes to getting initial market products to production parts, and then at the end of the life cycle of the parts, even replacement parts programs. There are several major companies and major programs around the world that have announced that they would like to start using, or they're already started to use, additive manufacturing technologies for all of their replacement parts programs. And that includes some major automakers. There's some electrical equipment and appliance manufacturers that have done that as well. So that's a major driver that's happening in that area. Personalized products is another area. There's several automotive companies, for example, that are offering customization components for their vehicles. And these are all 3D printed. And you can only do this through 3D printing because 3D printing allows you the ability to highly customize a part and yet still have it within a certain budget or in a timeline that you're looking for. And then design complexity. You can design components using additive manufacturing. You can design components for additive manufacturing that can be highly complex. For example, parts that may not have been able to be injection molded or machined, you can now use the capabilities of additive manufacturing to achieve that. So you can probably look at the shoe industry, for example, where there are several highly complex shoe designs that are coming out that would have never been able to be manufactured any other way other than using these additive manufacturing technologies. So just to kind of wrap up, the advantages of additive manufacturing is essentially design freedom, market agility. You can mitigate the risks of tooling by testing out things very, very early on. Reduce costs of the entire program. Efficient low to mid volume production. There's also a flow in terms of a lot of companies that are looking to go from mass manufacturing to mass customization. We're seeing quite a bit of that. And additive also allows you to fail fast, fail often, and fail cheap. Essentially allows you to iterate very quickly so that you can go up on the iteration and the generations of your product development so that the product that comes out into market is a relatively mature product. And complete product life cycle. So I'm going to cover what that means is additive manufacturing allows and can be integrated into the complete product life cycle of a product. And what that means is essentially this. Additive manufacturing has obviously and for a long time been used for concept modeling and prototyping and things like that. And now more and more it's being integrated into the testing and qualifications of a product, where, for example, if a company needs to test out what a certain fit looks like, they'll print that out, or you can make test parts to calibrate your automation systems, for example. And then on the manufacturing side, we're getting quite a bit of low-rate manufacturing tooling, specialized shop aids like ergonomic fixtures and things like that, and jigs and fixtures, as well as end-use parts. There are major manufacturers around the world, including some of our clients, that are using 3D printed additive manufacturing components on their end-use products that will be out in the market for the next 10, 20 years. So it's a great application we're seeing in the manufacturing space. And then at the end of the life cycle of the products, we're seeing quite a bit of jigs and fixtures for repairing items, or repairing tools, or even using additive manufacturing parts as replacement parts programs. So like I said earlier, having replacement parts on a virtual warehouse can be a lot more sustainable than having actual parts in a real warehouse sitting there for whenever the support is required. So there are right across the board quite a bit of new and exciting applications and innovations happening in terms of companies and programs using additive manufacturing for their benefit and definitely for future sustainability. So the most common applications for additive manufacturing has been prototyping, tooling, and production parts, right? In prototyping, of course, you can improve time to market. You can essentially design things like concept modeling, design verifications, functional prototypes, and so on and so forth. But now we're also seeing the prototypes that are being developed using additive manufacturing, because the parts are being designed to be additively manufactured. That prototype is essentially an end-use production part that's been made. And so after a couple of design iterations and things like that, we can essentially take that prototype and our clients can use it or sell it as an end-use item. So we're seeing that kind of crossover quite a bit. And then of course in the middle we have tooling, which customized tooling is a major application in manufacturing, and sometimes on-the-fly designed tools that need to be applied and tested right away. We can help a lot of our customers do that, where they'll find a problem that will work with them to put together a design, and then within a matter of 1 or 2 days, they will have that tool so that they can actually test it out in the real space. We have a tool that we tested out in a car automotive application where they needed a specific guide for a fastener. This was a very hard to reach area, so we designed a tool for it and we sent it out to them in the next, might have been a couple of days. And it was so successful that we actually ended up making several dozens of these, and this company sent it out to all of their assembly facilities across the globe. So it was actually really, really exciting, good application for an example of tooling or additive tooling. So rapid prototyping has been around for a long time, and these are some examples of what rapid prototype parts look like. Believe it or not, that part right there is an actual 3D printed component, although it looks like cloth. Tooling, for example, that's an end effector for robotic applications, very, very successful application. So if you guys have any ideas for tooling or anything like that, let us know. We can help you on the design side of it as well as the manufacturing side of it as well. More and more from food manufacturing to automotive to just general automation to even farming applications, we're seeing more and more companies and programs wanting to use additive manufacturing, and we're helping them make that possible. We've made tools as small as several millimeters across to as large as tools for farm equipment, where high wear items in the front of certain rigs, we've been actually printing them using our very, very large printers that can print 3 feet by 3 feet by 2 feet, very large parts. We've actually supplied to these really, really large applications like farming and mining and those types of applications as well. So tooling is a very large area that additive is helping out with. Now, durable production parts has been the goal of additive manufacturing from the day one that it started. However, technology is just coming around to offer high degrees of customization and optimize the supply chains by having parts that are, first of all, as good, if not better, as the original parts that they were making with their classical technologies, and also made with materials that are very flexible. So we can make parts that are clear to opaque, flexible to rigid, or anything in between. We can even make parts with multiple materials in between as well. Some of the areas and some of the industries that are utilizing this technology right now, of course, consumer goods such as shoes, aerospace parts has been using that for a long time, and then high performance and low volume parts as well. Excuse me, I'm going to turn off my phone here. That's very embarrassing. So let's keep on going here. So additive manufacturing processes and technologies. I'm going to go over, now there's probably about, several dozen major additive manufacturing technologies. And but I'm going to focus on just the ones that we help our clients with. And then if you have any more questions about other additive manufacturing technologies or how these technologies can help you, feel free to reach out and we can have another discussion along those lines. So some of the major technologies that are out there is SLA, which uses a resin to build a part up, or POLYJET, where we use a resin and we spray it down layer by layer and build parts. FDM is very popular. If you know, it's essentially like a glue gun that builds layer by layer by layer. Multi-jet fusion is using powder and we spray a binder material on it. So and that makes incredible parts, and I'll talk about that. SLS uses powder and lasers to be able to build the parts. And DMLS uses metal powders and lasers to build parts. So these are very popular applications, and more industries are finding quite an interesting amount of applications there. So one of the major technologies we have in-house, and Proto 3000 is one of the largest centers for POLYJET 3D printing. We have POLYJET. POLYJET is the highest resolution 3D printing technology there is. You can build incredibly thin walls. You can make parts that are clear to opaque, flexible to rigid, from one color to another. It also offers quite a bit of functionality. We make, because of the resolution of the parts we can make with POLYJET, we can produce parts for tooling, for example, or that types of applications. And we can print in about 500,000 colors, multiple materials all at once. So if you're trying to do overlays of parts and things like that, we can do that. FDM, or fused deposition modeling, it is more of a rougher material, but it's a very functional material. And we have it's a very mature technology, so we can make quite a number of products using a various selection of usable materials as well. So anything from nylons to polycarbonates to ABSs to even really high performance materials, and I'll talk about that in a little bit here as well. Multi-jet fusion is a very new technology from Hewlett-Packard and several other companies, and we have a massive capabilities for multi-jet fusion in-house. Multi-jet fusion is very, what can I call it? It is one of the closest additive technologies to injection molding or machined parts there is. A multi-jet fusion part is isotropic inside, which means no matter what angle you cut it, it maintains a similar physical properties and strength properties. This technology is also about 10 to 50 times faster in terms of production. So we can really justify using a technology like this for production purposes. In fact, the hundreds of thousands of face shields that we're producing for some of the COVID-related programs right now, we're using this technology because it's very fast and it produces components that are highly functional and very durable. Stereolithography is actually the original 3D printing technology. It allows for really high layer resolutions, quite a number of materials. It's not as functional, but it does offer quite a bit of functionality if you're trying to produce clear parts or very smooth parts or high finished surfaces and things like that. Laser sintering is also older technology. It does produce a rougher material, but you do have the options of quite a bit of material powders and things you can select from, including nylons and so forth. So when does additive make sense? So it really depends on, and a lot of our clients reach out to us early on in their project development and product design to figure out what technologies will fit to whatever you're doing. So in terms of, in terms of product ideation and design and testing, and even market introduction and pre-production parts, that's where some of the latest technologies like multi-jet fusion and DMLS, direct metal laser melting or sintering will actually work out. On the production ideation and prototyping side, that's where technologies like POLYJET, SLA, FDM, and laser sintering and some of those technologies really make sense. Eventually, though, once the additive technologies become a little bit more faster, I think we can get more and more into medium to high production numbers. And that's going to happen really soon as we watch this space. So additive materials, you can sort of split up into standard plastics, engineering plastics and elastomers, high performance plastics, photopolymers, and then metals. Now, we have sort of a list or numbers on top of there. That's sort of like the numbers of plastics that are available, but honestly, on a weekly basis, there are more and more and more polymers and metal mixes that are being developed. If you're interested, you can also develop your own metal technology or metal or plastic technologies available. With these materials, you can select and design for heat resistance, biocompatibility, chemical resistance, UV stability, high strength, transparency, elastomeric properties or static properties or rigidity or toughness or anything like that. So additive manufacturing is going the way of classical technologies where the material science is really starting to catch up. So one of the technologies I wanted to talk about is polymer binder jetting material. This technology allows you to make parts out of nylon, TPUs that are flexible, glass bead materials that are nylon, which are very rigid. And this is the technology from Hewlett-Packard, the multi-jet fusion technology, where you can print thousands of functional components because it's very fast, and also the material is isotropic, very similar to an injection molded plastic material. These are some of the FDM thermoplastic materials, anything from ABSs to polycarbonates to ultims such as and Teros, which have really high temperature resistance capabilities, to also soluble materials where you can produce a soluble part, you can wrap fiberglass or carbon fiber around it and melt the inside out, and then you're left with your part. So you can make sacrificial parts like that as well. So this is an idea of what POLYJET materials look like. As you can see, you can produce parts that are anything from a concept to detailed design of the inside to final product on the right side, which with the certain textures and the etchings and all those details that you're looking for. So technologies like POLYJET are very flexible in helping that design life cycle. So industry uses and case studies. I have about 5 of these and I'll kind of blow through them really quickly. Aerospace is a very big industry where additive has been used. It's been used for things like wind tunnel testing, where you can produce a prototype vehicle or a component. You can create fiberglass layups for it, like I said, where you can create fiberglass parts or you can create sacrificial parts. You can also produce surrogate parts for the purposes of testing out an automation line or anything like that, or composite aerostructures for tooling, and also production parts. We actually produce 3D printed production parts using Ultim that will and that are being installed in flying airlines right now, and that we've been doing this for probably the last 10 or 15 years. And in terms of benefits, using additive, you can produce lighter components, advanced functionality of the components, improved fly to buy ratio, where you can produce parts that can be almost ready to go. Increased supply chain efficiency, reduced inventory requirements. We produce additive manufacturing components in time, in line with our clients' timing requirements for installation times or assembly times and things like that. And then rapid on-site production of assembly tools that can happen using additive manufacturing as well. So the Airbus A350 has over 1,000 flight-approved FDM 3D printed components. So that's just a really interesting fact. A very successful airline in its regard, and in order for them to meet the timelines, very strict timelines that they had in order to get their vehicle to market. They just skipped the tooling and they went with high performance plastic additive components, which not only saved time in terms of timeline for the vehicle to be out, or the aircraft to be out into market, but also it saved time in terms and space in terms of inventory as well. So they were able to produce the components as they needed them. Very, very interesting application. So driving and automation, automotive and automation is a very big area. Automotive, a lot of automotive companies are starting to use this technology, obviously the concept modeling, and again, wind tunnel testing and things like that, but also soluble supports for carbon fiber applications. For example, hollow carbon fiber wheels are being produced by several manufacturers right now for using a soluble 3D printed parts, wrapping the carbon fiber around, melting the inside out, and then you have your part. Several major companies, for example, like Ford and VW, BMWs, they've announced that they are producing additive manufacturing components for their vehicles. In fact, I believe BMW announced they just produced their millionth additive manufacturing part. And then companies like, or smaller programs like the Mini program from BMW, they're offering 3D printed customized components that clients can produce, and they will ship it out to the client to be installed on their vehicles. So really, really interesting applications going on where, you know, typical industries like automotive, where they've done mass manufacturing, they're now looking to see what they can do with mass customization. So Volvo Trucks had a really good application for this one tooling that they needed to produce, and they essentially saved about 94% of time in terms of producing this component. And I believe there was in terms of time, they were able to produce the part in 2 days compared to what it would have taken about 36 days if they were to use their classical way of producing this component. So healthcare is also a very big industry that is using 3D printing. Orthotics, bionic prototypes, pre-surgical models. For example, if you want to practice on a specific surgical model of that patient before you actually work on the patient. Personalized prosthetics is a big area. In fact, we have supported and Canada's winningest cyclist, her name is Shelley Gauthier, where we have designed, optimized, and made using additive manufacturing technologies. In fact, our HP multi-jet fusion technology, we've produced her prosthetic bracing for her arms and her legs, as well as we produced her customized handlebars to fit the way that she rides the bike. To this day, she has probably put on maybe about 1,000 hours on all of those components. And those components not only met the performance of the original components, but they beat them. So they were either lighter or stiffer or more comfortable. So it's a great real life application for personalized prosthetics. Surgical instruments and surgical tooling is a very big area that we're using additive manufacturing for, and then also medical simulation and things like vascular training and things like that. So the benefits are, of course, very similar to some of the other areas. You know, less time in the operating room when you're using pre-surgical models, improved procedural outcomes from medical simulation components, and better standard of life for the clients or the patients that are using prosthetics and bionics and orthotics. So one of the areas one of the things that we can do with POLYJET technology, for example, is modeling. So I think that's, and then the final part, and I see Robert over there as well. I'm just going to kind of wrap it up. The final application is consumer products, where we work with a lot of clients to produce consumer products for concept modeling and even end-use components that can be used. So OtterBox is actually a really good example where they started with 3D printing some of their products before the market. So anyways, that was sort of a lot of information for you, and you know, I want to encourage you to get a hold of us. if you want to talk about a very specific project or anything like that, and we can really hone down and advise you on the best way forward using any of these technologies for anywhere in your product life cycle. So anyways, thank you for that. I'm not sure what the timing's like. It's 2:05.
Yeah, you're good. No, you're good. We still have a few minutes left for some questions. Not too many questions, but I do want to mention, though, for sure, please, check out their booth, go and connect with them, ask the questions now, or even just, schedule some time with them at some other point, for sure. Victor, that was great. So I just want to, there's a couple of questions. I want to go through them. So if you don't mind,
please.
just give me a second here. What typical limitations do you see, if any? And then there's like materials, process, and quantity limits. Is there any kind of limitation? I guess that's what they're looking for.
Yes. So there's limitations with every technology, and especially newer technologies like additive manufacturing. But what we found is, in terms of material choices, if you're looking for very specific plastics or metals, they may not be available. But that being said, most of the popular polymers and metals are available. Some of the limitations, I would think quantity would be a limitation. If you want to produce 1 million parts, we would probably not recommend using additive manufacturing. We would probably recommend you produce the first 100,000 that can go into market right away with certain speeds using manufacturing or using additive manufacturing. But we would then sort of encourage you to work with some of the classical tooling to get, the quantities out. And then the other limitation, which you probably didn't mention over there, is pricing. A lot of people will reach out to us, say, hey, can you make this part for $2? Well, that's sort of not how additive manufacturing necessarily works. We have found that even though the unit price of a part may be a little bit more expensive than, let's say, injection molding it, we're able to help reduce the timelines and also the program cost, the total program cost, by using technologies like additive manufacturing. So there are limitations, but if you want to talk a little further, we can chat, and we can go over sort of the possibilities of what's possible with additive manufacturing as well. So probably, I think the final thing I could probably say is manage your expectations in terms of new technologies, and that includes additive manufacturing. But things you can do with it may surprise you.
Awesome. Got one more question, but it actually might even be for me, because it says, what are the Autodesk technologies that can integrate to the additive manufacturing solutions? Well, I guess we can both answer that, but I can tell you one thing, it's definitely going to be, the Autodesk products like Inventor, the flagship manufacturing product for Autodesk for over 25 plus years. Fusion 360, hottest topic today. A lot of technology there growing. Additive manufacturing is part of the solution, actually, within that product portfolio right there. And as well, Autodesk has a specific 3D printing software that allows you to work with components and post to many different machines out there. So it's a single source kind of thing. It doesn't have to be for a specific machine, but it's NetFab, which even allows you to automatically 3D nest in a volume, in your print volume. So that's pretty cool stuff, I guess. So there's the majority of the Autodesk products that can actually work well with your technologies, right?
I would second you on that Fusion 360. I think what's great about Fusion 360 is it's so accessible. Even if you're an individual person, it's an accessible program that you can get within your budget and start using it right away. And then, it's sort of the gateway to everything else as well. So it's a great product.
And you have to start off with a design somewhere, and what other better product to design it in is a very easy product to use, like Fusion 360. So awesome.
Exactly.
Yeah, well, we don't have any other questions. I guess we can cut it kind of short today, but I know there's some other great sessions coming up. Again, thank you very much, Victor, for your awesome presentation. I hope everybody got a lot out of that today. And as well, don't forget to check out their booth, like I said before. And stay tuned for the other sessions coming up really quick. Thank you.